So we know the importance of delta time. If we're moving things or rotating things, we want that movement to be independent of the frame rate. So for that, we can get delta time.
Oh,
I
no.
can simply include gameplay statics, and if you have a good memory, you'll remember that the include is kismet/gameplay statics. So I'll get gameplay statics in here so I can access the static function get world delta seconds. And remember, this requires a world context object, so I'm going to pass this into that. And last,
Buddy.
we need an interp speed. The higher the value of interp speed, the faster we will interpolate towards the target. So if I set this to a value of, say, 5.f, then we'll interpolate fairly slowly. Let's see how this looks. Now, all of this is on a single line, and it runs off the screen. So what I'm going to do is place the input to set world rotation on its own line like this. So just like that. And then our interp2 has these 4 input parameters also running off the screen. So I'm going to set them each on their own lines. That way we can see all the inputs without having to scroll off the screen like that. All right, I'm going to go ahead and save that and kick off live coding. And now if I press play and I move the mouse, notice that it's taking a while for that rotation.
Live code. Live game. Delta statics. Did I spell it wrong?
It's getting the rotation. Now the next input is an F rotator called target. That's the value we want this turret mesh rotation to interp to smoothly approach. That's going to be our look at rotation. So I'm going to say look at rotation. The next input is delta time. So we know the importance of delta time. If we're moving things or rotating things, we want that movement to be independent of the frame rate. So for that, we can get delta time. I can simply include gameplay statics.
Aha.
And if you have a good memory, you'll remember that the include is kismet/gameplay statics. So I'll get gameplay statics in here so I can access the static function get world.
This is wrong. The variable.
Delta seconds. And remember, this requires a world context object, so I'm going to pass this into that. And last, we need an interp speed. I
need to pee. I need to use the bathroom. Why? Why? U gameplay statics is not a class for namespace name. I disagree. No, I don't disagree. The P isn't capitalized. It's not the first time I've made that issue, made that error. Should be good now, should be good now. Compile that. Bang! Successfully linked.
higher the value of interp speed, the faster we will interpolate towards the target. So if I set this to a value of, say, 5.f, then we'll interpolate fairly slowly. Let's see how this looks. Now, all of this is on a single line, and it runs off the screen. So what I'm going to do is place the input to set world rotation on its own line like this. So just like that. And then our interp2 has these 4 input parameters also running off the screen. So I'm going to set them each on their own lines. That way we can see all the inputs without having to scroll off the screen like that. All right, I'm going to go ahead and save that and kick off live coding. And now if I press play and I move the mouse, notice that it's taking a while for that rotation to happen. That's because we're smoothly interpolating towards that target rotation. Now, this is great. That's exactly what I wanted. No matter how I move my mouse, I'm never going to get that snappy, jerky, sporadic movement. Now, 5 is an awfully slow interp speed, but we can change that. We can make it a little bit faster. I'm going to set this to 25, see how that looks, and I'll let you go ahead and decide on the value that you like for your game. So, one more time, kicking off live coding and pressing play. Now I have a pretty fast interpolation, but it's not snapping. It's still quick, but it's not an instantaneous snap. So as long as we're not doing something like this, well, we won't get that crazy behavior. And of course, if you want a slower rotation, you know how to do it now. And we're done with draw debug sphere, so I'll go ahead and remove that. Okay, so in summary, we've set the turret rotation, and we're passing in a lookout target, which is an F vector corresponding to a point in the world. Right now, we're just using the trace hit result. Now we put this function in the base pawn class and made it protected, which means that we were able to inherit the function in the tank class. And once we're ready to create a tower class based on base pawn, then that tower class is going to inherit this rotate turret function, and we can reuse it. All we need to do is pass in a new lookout target. We'll work on creating a tower class derived from base pawn in the lectures to come. I'll see you soon. Hello and welcome back. Now we've created a tank that can move around and even rotate its turret, and we're ready now to create a tower class that can inherit some of the functionality that the tank inherited from the base pawn class. Now once we've
Over here.
created a tower class, we're going to override the tick function so that we can rotate its turret as well. So our goal here is to have the turrets rotate so that they're always looking at the tank. This way, when they start firing projectiles, they'll hit the tank sometimes as long as the tank isn't moving out of the way quickly. And we're also going to figure out how we can get a hold of the tank pawn. That way, we can target the tank pawn and rotate the tower's turret toward the tank pawn. We're getting ready for some projectile combat. So I'm here in the editor, and I'm going to go into our Toon Tanks folder where the base pawn and the tank classes are. Now, I'd like to create a tower class based on the base pawn class. Now, the way we did this with the tank class was we right-clicked on base pawn and selected Create C++ class derived from base pawn. An alternative way is to go to Tools and select New C++ class. And from here, we create C++ class derived from base pawn on the base pawn class. Now, the way we did this with the tank class was we right-clicked on base pawn and selected Create C++ class derived from base pawn. An alternative way is to go to Tools and select New C++ class. And from here, we can click the tab that says All Classes and search for base pawn. And here we see our base pawn class. If I select this and click Next, now I'll be creating a new class based on base pawn. I'm going to leave it in the same path as all our other C++ classes, and I'm going to call this Tower. So let's click Create Class. So here's my new tower.h and tower.cpp. Now the first thing we need is the tick function because the tower is going to want to rotate its turret to face the pawn. So we're going to override the tick function here. So I'm going to make a new public section. And we're going to type virtual void tick, which takes a float called delta time, and this is an override. Now, we'll get into more detail about virtual and override in future videos, but we're essentially taking the inherited tick function and creating a new implementation for it. So let's take the tick function and implement it here in tower.cpp. Now, we need to prefix the tick function name with a tower and the double colons, and as always, it's a good idea to call super tick, and we need to
Ow, don't bite me!
Now, what I'd like to do here is rotate the tank turret so that the tower is threatening the tank and ready to fire projectiles, but I'd like to do this only if the tank is in range. Now, in order to know whether or not the tank is in range,
H.
tank and ready to call a new implementation for it. So let's take the tick function and implement it here in tower.cpp. Now we need to prefix the tick function name with a tower and the double colons. And as always, it's a good idea to call super tick, and we need to pass in delta time. Now,
don't bite me.
Here is rotate the tank turret so that the tower is threatening the tank and ready to fire projectiles. But I'd like to do this only if the tank is in range. Now, in order to know whether or not the tank is in range, we need to know the distance from the turret to the tank. Now, here's a little gizmo that represents the origin of the world. In other words, the point in space where x, y, and z are 0. Now, when we talk about an actor's location, we're talking about the vector from the origin to that location. And we can always get that location vector using getActorLocation. So we can get the location of one of the towers and the location of the tank, and if we know those two locations, we can calculate the distance between them. Now, we could do this with vector mathematics, but the fvector class has a function called dist, and this function takes two location vectors, and what it returns is the distance between them. So here in the tower.cpp file, in the tick function, I'm going to write a couple of notes just so we know what we're supposed to do. First, we need to find the distance to the tank. After that, check to see if the tank is in range. And if in range, rotate turret toward tank. So we have some to-dos here. Now, in order to find the distance to the tank, we need to get a hold of the tank. Now, a good place to do that is in begin play. So in addition to the tick function, let's go ahead and override begin play. Now notice in tank.h, begin play is in a protected section. We're going to keep it protected in the tower.h as well, so we'll place the protected section just under the public one, and we'll implement begin play just under tick. So let's go to tower.cpp, implement begin play, fully qualify the function name, and as you probably guessed, we're calling super begin play. Now, in order to get the tank and store it in a variable, we need a variable of type tank. So we're going to place that here in tower.h in a private section. Now, this is going to be an a tank. It's a pointer, and we can simply call this tank. And in order to avoid having to include tank.h here, we can forward declare. We've seen how important that can be. So now we have this tank pointer, and if we can figure out how to access the tank, we can store it in our tank pointer here in begin play. The first thing I'm going to do is include tank.h, so that way we can actually use the type. So how do we access the tank? Well, here's the Unreal Engine documentation for a handy function called getPlayerPawn. It exists in uGameplayStatics. So since I have this open, I'm going to go ahead and copy the include for gameplay statics and take a look at the syntax. It has two inputs, a world context object, we already know how to handle that, and a player index. And as we saw, for single-player games like ours, the player index will always be player 0, and that will allow us to access the pawn corresponding to player 0. So let's call this function. Here in tower.cpp, I'm going to paste in the include for uGameplayStatics, and in begin play, I'm going to set tank equal to uGameplayStatics getPlayerPawn. For the world context object, I can pass in this, and for the player index, we can pass in 0. Now check out the red squiggly. It says a value of type a pawn cannot be assigned to an entity of type a tank. This is the same exact issue we ran into when we were attempting to call getController and store the result in an a player controller. A tank is a child of a pawn, so we can't store a parent type in a child pointer. We have to, you guessed it, we have to cast. So we're going to take the value returned from this and put it inside of a cast function call. So we're going to say cast, and we're casting to a tank, and what we're passing in to cast is going to be this call to get player pawn. So let's put that right there in the parentheses, and after the cast, we will have access to the tank. So now that we have access to the tank, we can find the distance to the tank. And a distance is a float. So we can make a local float variable called distance. And what we're going to set it equal to is the result of calling the fvector static function dist. Now dist takes two input parameters of type fvector. Now we want the distance between 2 points in space. One is the tower location. We're in the tower class, so we can call getActorLocation, and that gives us the location of the tower. But what about the tank? Well, we can call tank getActorLocation. And now we have the distance. Now the only issue is that we're using the tank pointer without first checking to make sure it isn't null. So we have to say if tank first, and then we can take this function call and drag it right here inside the if statement. So if the tank is valid, then we can access its location with getActorLocation. Excellent. Since we're working in this if statement, I'm going to move these other comments here inside of it, because we know we can't check to see if the tank is in range if the tank isn't even valid. So I'd like to challenge you to rotate the turret towards the tank. Now we only want to do this if the tank is in range. We have the distance, so now we need a fire range variable. So create a float called fire range in the tower class and expose this with uProperty. We'd like to be able to edit this from the editor. Now, you're going to check to see if the tank is in range. If it is, call rotate turret. And rotate turret needs a look at target. You're going to pass in the tank's location. So pause the video and implement this behavior now.
What does F vector dist do? Less than fire range. We're gonna rotate, which we did here.
Okay, so we need a fire range variable. So here in tower.h, we have a private section. We're going to make a float. I'm going to call this fire range. And I'm going to go ahead and initialize it to a value of, say, 300.f. But we'll experiment with this because it's going to be a U property. So U property And since I'd like all of the tanks to have the same fire range, I'm going to make this edit defaults only. So that way we can only edit it on the default blueprint. Now, if you made yours edit anywhere or maybe edit instance only, that's totally fine. It's really a matter of preference, and we can change it later. I'm going to give it a category as well, and I'm going to call this category combat. Let's go into tower.cpp, and we have this next point here, check to see if the tank is in range, which means we need to check to see if distance is less than or equal to fire range. We have less than or equal to, and not just equal to, because from frame to frame, the distance may actually be greater than fire range one frame and less than fire range the next frame, completely passing fire range, so it may actually never become exactly equal to fire range. In fact, with floating point values, two floats being exactly equal is quite rare. So we have this if check, and if we get to the inside of it, that means distance is less than or equal to fire range. The tank is now in range, which means this comment can be moved right there. Now, if in range, rotate the turret toward the tank. That means we're going to call the rotate turret function. That's our protected function that we put in base pawn. Now, rotate turret takes a look at target, and we need the location of the tank. So that's going to be tank get actor location. And with that, we are now calling rotate turret only if the tank is in range. So let's compile this and see how it works.
Where's look at tank? We didn't need this. Okay. This is in base pawn.
So we're back here in the editor, and what we need to do is go into blueprints, pawns, and find a BP pawn turret, and open full blueprint editor. Now, up at the top right, we see parent class base pawn, but we want our parent class to be the tower. So
Whoopsie doozle. Okay.
we can go to class settings, parent class, and search for tower, and select it. Now our pawn
Class settings. Parent class. Tower.
turret is based on the tower class. Now let's see what happens when we hit play. Okay, so I'm moving the tank around. We're not in range, so we don't see any movement from the towers. But if I get in range, look at that. Now they're following me around, and it looks quite threatening. Now, 300 units is not that far away, so what I'd like to do is edit that distance. So from here in BP pawn turret, I'm going to select BP pawn turret self, and here's the combat section. I'm going to go ahead.
Ah.
Ahead and set this to about 700. Now if I hit play, I'll see that they won't be rotating while I'm moving back here, but as soon as I get in range, now they're looking at me. Perfect. So in summary, we have created the tower class. We now have an enemy for the tank. We also rotated the tower's turret toward the tank in the tick function, and we're only doing so if the tank is in fire range. We also exposed the fire range variable so that it can be adjusted in the blueprint. We're almost ready for combat. We'll start setting that up in the videos to come. I'll see you soon.
Okay, this is where I leave you. Let's just rebuild this. We're linked. Pow, 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 pow. Dead. Fire, fire, fire. Fire! Fire! I would like the camera to follow. I'm just gonna Control-Shift-B. Full build. Unable to build while live coding is active. I just shut it down, baby. And in the meantime, let's get Minecraft going. We're making the switch. We're gonna craft. Oh, baby.